Welcome, everybody. We're still waiting for a few more participants to join us, so we'll give it a minute and then we'll get started. So today we're carrying on with the TCA's Pathway to Sustainability webinar series. We're bringing you a fresh look at the technical, economic, and environmental advantages of hybrid mass and timber construction for contemporary building projects. This webinar will explore how combining the strength, long span capability, and constructability of structural steel with low carbon, biophilic qualities and prefabrication benefits of mass timber can deliver highly efficient structural systems. Before introducing our speakers, I'd like to read a short excerpt from an advertisement for this year's third annual Mass Timber Construction Conference being held in March the 4th and 5th at the Crown Plaza in Toronto this year. In recent years, Canada has positioned itself as a global leader in the rapid growth of mass timber construction, a trend quickly gaining momentum. According to a Global Newswire report, the global mass timber market is projected to expand at a compound annual growth of 14.2% between 2022 and 2029, fueled by Canada's proactive adoption of mass timber technologies and its focus on sustainability. Despite its promising growth, Canada's mass timber industry remains in its early stages, contributing roughly $400 million annually and accounting for just 1% of all construction projects. Canada's share of the global mass timber market was $379 million in 2023 and continues to expand. Even without additional manufacturing capacity, mass timber production in Canada could contribute an extra $649 million to the economy by 2030. However, increased production capacity and efforts to capture 25% of the global market could push Canada's economic output for mass timber to over $1.2 billion by 2030. One of the projects which are being done in Canada by West Group Properties, River District, is a mixed-use development project that will feature an 18-story mass timber tower and podium and a 7-story building, providing approximately 240 units of rental and strata housing to Vancouver's Killarney neighborhood. The building's construction will include mass timber and steel hybrid and will leverage prefabrication for the balconies to reduce thermal bridging and increase air tightness. This is encouraging provinces across Canada to update building codes to promote mass timber constructability nationally. Our distinguished visitors, we could have the next slide. Our distinguished visitors today include two professional engineers specializing in mass timber projects and large-scale structural steel projects, with a strong focus on sustainability and low-carbon construction. As Element 5's Director of Sales in North America, Lee Scott has worked on mass timber projects of all sizes and has an intimate knowledge of mass timber design. As the Director of Engineering Solutions at Steelcon, Scott Norris is a recognized advocate for sustainable design and is a champion of hybrid steel and mass timber construction. We encourage our viewers to submit questions to the panelists by adding them to the Q&A box, with the questions being addressed at the end of the session. Lee, you're up.
Great. Thank you, Sandra. Good morning, everybody. Thanks for joining on a Monday morning. So excited to be here and talk a little bit about mass timber. Wanted to give just a quick overview about Element 5. I'm sure there's quite a few people on the phone that are familiar with us, but we have been in the mass timber game now since about 2015, but in 2019 we actually started construction on our facility in St. Thomas. So bringing a local solution of mass timber here to Ontario. So we're Ontario's only manufacturer of CLT and glulam. And we started in 2019 by building a 140,000 square foot facility in St. Thomas. So you can see there, we have 2 fully automated production lines that we started out with. A very high capacity in the North American market for cross-laminated timber. So that's typically used for the floor and roof and sometimes wall assemblies of the mass timber building. You typically, cost effective in a horizontal floor plate. So 50,000 cubic meters, that translates into about 3 to 4 million square feet of floor plate that we could make using a 5-ply CLT slab. We didn't have quite a large capacity for glulam. So last year we actually, 2 years ago, we partnered with a company, Hoschlacher, out of Europe, and they invested in Element 5 to help us with this expansion. So you can see we've gone from about 140,000 feet to over 400,000 square feet at our facility at St. Thomas. We've added a mass timber office. Scott, I think if we click through here, there's a few bullets that come up. So mass timber office, we've added a glulam line, so 10xing our glulam capabilities. So glulam is typically for the vertical support structures, the columns and beams of the buildings. We've got a lumber grading and sorting facility with a really cool piece of technology called the Golden Eye. It's basically a huge X-ray machine with 21 cameras that's fully utilizing the Ontario supply chain that we have for lumber. So instead of just our visually graded lumber going down to the US to build houses, we're actually able to take that, regrade it, sort it, and use it to its full potential in our mass timber buildings. We've got a beautiful canopy logistics area. If you come out to the factory, you can see some really cool pieces of glulam we brought over from Europe. And the new glulam line. We've got 5 CNC machines actually running around the clock, 24/7, cutting up the billets that come off the line so we can deliver them fully fabricated and ready to assemble on site, basically like Lego. Next slide, Scott. So Element 5, we've really been building up our team. So it takes a village to get these buildings up cost effectively, on time, on schedule, and efficient. So we built up a great team on the design and consulting side to help projects from early stages. So if you come to us with something in concept or schematic design, we can give you very early feedback on pricing, design iterations, and hopefully get to a point where everything looks palatable to move forward and actually kick off the project and bring in our full engineering team. So we have about 20 engineers on staff now, architectural detailers, modelers, and obviously we're making everything down at locally at our shop in St. Thomas. We're working with preferred installers, steel fabricators, carpenters, people all across the country in order to put these buildings up. Element 5 is not an install company, but we want to be part of that conversation and process from very early on to ensure that what we're bringing to site comes in the right order, matches the construction sequence, and everything is going to go up smooth and efficiently on site. Next slide, Scott. So I'll pass it over to Scott. He can give you a brief overview of Steelcon.
Thanks, Lee. So Steelcon's a privately owned company. It's a privately owned Canadian company with 859 employees. We also have a large in-house engineering and detailing group to kind of do assist with the maybe design assist or look at optimizations or things like that, like Lee was talking about, or to just work through the process and make sure we're on top of it with erection scheduling and helping the clients deliver the project on time and on budget. We have 6 locations, 5 of which are in Ontario, around the Western GTA region, and then one of them is down in Georgia in the US. We have 886,000 square feet of shop space and about 110,000 annual ton capacity of structural steel. Along the bottom, we have a number of lines of other manufacturing, our proprietary sin beams, steel joists, metal deck, and our own in-house erection team. We operate in many different sectors, industrial, retail, hospitality, healthcare, and mixed use and education, so kind of across the board. So I'll pass it back over to Lee to kick it off with the strengths of mass timber.
Yeah, I think one of the reasons that everybody, mass timber is so popular right now is because it does add a lot of value to a lot of different stakeholders. It brings a lot of different areas of value. So one of the strengths of mass timber is that it is, it's lighter than, it's light. So we can build buildings on site classes with geotechnical site classes that we may not have been able to build a full cast in place concrete building on. Since timber is 5 times lighter than concrete, 16 times lighter than steel. So that does help with reducing foundation costs, reducing the amount of concrete we need there. And the level of prefabrication that we're able to do in the factory, we're able to get these buildings up extremely quickly. So it does bring a lot of value in terms of offsite prefabrication, the installation speed, fire performance, and we're going to talk a little bit about the biophilic benefits as well. So as you can see, the building behind me brings a lot of beautiful warmth and health benefits. So this is actually a full mass timber building that we did in New York City, but it's just a great example of what a mass timber building can look like in a multifamily situation. So this building was actually on the cover of Architectural Record magazine last year. It's a bit of a hybrid building in the terms that it's got concrete cores and post and beam tying into it, but a beautiful example of the biophilic benefits. So there's a lot of studies out there right now about how people can be happier, healthier, and more productive in a wood building. And, it actually has a good benefit on people's mental health, lowering heart rates, lowering stress levels. So those are the types of aspects that we want to bring to people's work environments where people are living, going to school, and resting their heads. So next slide, Scott. Construction schedule. Quite a few general contractors in the audience this morning. So this is one of the great attributes of offsite manufacturing. And I think that tying mass timber and steel together in a hybrid scenario really brings the benefits of speed of both typologies. Like I said, we are able to start manufacturing the building while we're doing the site work on site. So the timber structure, along with the steel fabrication, can be going on while the site work and foundations are being prepared. Hopefully, we're able to use a lot of that wood in an exposed condition. So we're actually lowering the amount of trades that we need on site, lowering the amount of materials needed on site. And basically, the mechanical and electrical plumbing integration and penetrations through our elements, through our beams, through our panels, all of that is coordinated up front. So there is a bit longer design process in order to iron out a lot of that coordination and make sure that we have those represented well and accurately on our shop drawings. But once those materials get to site, all those penetrations are already cut. So, well, the majority of them anyway. So they're typically going to do a threshold of say 3 inches or higher that we're going to cut those penetrations in the factory. You can still do penetration cuts on site. It's quite easy to cut through the wood. It smells good and you're not going to hit any rebar. But having that electrical and mechanical plumbing pre-coordinated, that's just going to give you more cost certainty, less RFIs, less coordination, less site instructions, and allow that building to get fitted out quickly. So not only does the structure go up quickly, it's able to get fitted out extremely quickly because of that upfront coordination we're doing. I mentioned hopefully we're leaving that wood as the material, the finished material. A lot of that has to do with the fire rating of the building, whether we have to encapsulate it, and just trying to get the most cost-efficient volume of wood into the structure. So all of these factors combined can really compress the construction schedule. I know Scott's going to talk a little bit more about that, but marrying steel where it makes sense and wood where it makes sense, really to get the best overall results and taking advantage of the attributes and the benefits of both of those. So a lot of the same processes and detailing and offsite manufacturing go into mass timber as they do steel fabrication. So that's why these systems, when coordinated and designed properly together and efficiently, can result in a very cost-effective building that is going to go up and take advantage of all those offsite manufacturing benefits. Next slide. So talking a little bit about fire, one note is it's interesting that we are typically designing steel connections to be concealed within our mass timber so that the steel is actually getting protected by the wood from fire. So wood burns slowly and predictably. You can see the char layer there that we see. typically, if you're trying to hit a 1 hour or a 2 hour or 45-minute fire rating, we know how much char there will be after that fire event, after that time. And basically, we just need to have enough structural capacity left in the panel or the element in order to hit that fire rating. So it's quite an easy engineering calc to understand. If we have a 1 hour fire rating, typically a CLT slab will inherently get a 1 hour fire rating without adding any extra encapsulation or any coatings or anything. It's just, it's got such good mass that char layer protects the interior wood and allows us to hit that 1 hour fire rating. Even if we need to hit a 2 hour fire rating, you're probably designing a little bit more for that 2 hour fire rating, but we can still achieve the 2 hour fire rating with some very cost effective CLT layups that we have. So don't be scared about, it's wood, it's going to burn. We've gone way past that challenge, and there's tons of great solutions for that to leave that wood exposed. Also, the code is catching up. So 6 stories and below in Ontario, we're able to expose tons of that CLT by code. And if you go beyond 6 stories, typically when you're going to a 2 hour fire rating, the code is going to call you to encapsulate a little bit more of that timber. However, you can go through an alternative solution, and tons of the jurisdictions in the Ontario, especially Toronto, have gone through these alternative solutions, and it's almost boilerplate at this point to get more of that timber exposed. Next one, Scott. Acoustics, I'll just touch on this briefly, but super important because wood is light, sound does travel through it quite easily. So you do have to take some preventative steps in order to hit your STC and your IIC ratings. Again, working with a great acoustic engineer from the start of the project to ensure that your panelization, other design criteria are taking into account considering acoustics. So, for example, a 5-ply slab for CLT is going to get about an STC 41. We're going to need minimum 50 for a multifamily setting. So we're going to put down an acoustic mat, like a Plytech Genie mat or something of that sorts. That's anywhere from 3/8 of an inch to an inch thick, depending on what STC rating you're trying to hit. And typically, we're going to put down like a non-structural gypcrete topping as well, in order to hit both your STC and your IIC rating. So acoustics are important. It's a challenge, but we've overcome these challenges. We've got great cost-effective solutions for them. So I'll pass it back to you, Scott.
I'm sure everyone on the call is familiar with the strengths of structural steel, but we'll go through these quickly just so we can later on align between mass timber and steel and see how these can be used together to benefit the structure on a whole. So again, as Lee was talking about, offsite fabrication happening in a controlled environment, which this allows us to have tight tolerances and repeatable quality. There is connection simplicity and flexibility, and a highly mature supply chain. From an erection standpoint, we have fast and predictable erection, and this allows for reduced site labor and reduced trade overlap. And these members will have immediate load carrying capacity. The in-service performance, so there's a high strength to weight ratio, which allows for long open spans. We have a high material stiffness, which again reduces deflection and gives us that benefit for long open spans. We have a durable material with dimensional stability and understandable fire performance. Steel has high recyclability. I believe about 90% of the steel that we produce goes back into the system as scrap and is recycled down the road in electric arc furnaces. So the sustainability concept there as well. Then there's flexibility for future adaptations due to the materiality and the ability to weld and reinforce. We can do retrofits and accommodate changing occupancies in for future projects. So with these two, the strength of these two materials, you start to see some similarities, as Lee was pointing out, the offsite manufacturing, the speed of erection, all these items. So now it's the whole point of hybrid structures is how do you look at the building and optimize each individual member or each individual system for the best benefits of each component in order to create the best overall outcome. So that's how I see hybrid systems, is kind of like what you see in this building. Is they've gone through and picked and chosen based on their the project requirements, what makes the most sense to be what material, and what material properties benefit each individual element the most, and gone with that approach. So we'll start out quickly looking at building layout and structural grids. So as Lee was mentioning, mass timber, the CLT, you have a lot of benefits with the panels, wall panels, roof, walls, and floors. So you have that immediately there for the sustainability of benefits. And then when you start looking at vertical structure, you look at the few different cases that I'll highlight here. One, which is the point supported CLT, timber and beam CLT, or mass timber, and then the structural steel beam and column. And so there's a varying efficient bay and kind of upper bounds. So if you look at those differences, you can start to see that you can reduce the column count based on this, the optimal span. So that's where you'll start to see, where you have some challenges potentially in mixed use buildings occurring at the podium level, where you're trying to transition to retail and then to parking. This is where you can get some benefits in the hybrid approach, where you are able to reduce your column count. And we'll go through the first couple examples. You've got a point supported system with these shorter spans of structure, the shorter structural grids. And you'll see at the upper level with your residential units, the column spacing comes down to the retail space, and you have a very clear difference between the grid spacings at the residential versus the retail. And then again, as you go into the parking structure below. So you're trying to navigate this change in grid spacing, which likely requires a few levels of transfer in order to be able to change that residential spacing, which works very well in the upper areas. And then when you want more clear space, open space for retail, you may end up using a transfer slab, or depending on what your capacity is, transfer structure. And then you're into when you get to the ground floor, again, you're at a position where you're going from the retail space out to the parking grid, which is respecting the parking stalls and drive aisles. So you're dealing with potential, large potential of transfer structure to accommodate this, which brings in a lot of impacts from formwork and from curing and from weather delays and things of that nature. As you move over to the post and beam on the right-hand side, you're able to potentially eliminate that discrepancy between the residential and the retail space below, but you're still kind of stuck at that ground floor level where you have a transfer issue, and you're dealing with again transfer slab, which all the impacts that we discussed previously. So then when you start to look at the hybrid solution, you're able to get those slightly larger grid spacings, and it allows you to be a little more flexible to align the structure up. You're still dealing with 3 different spacings, so you're never going to be perfect. You're never going to totally eliminate that issue. However, it allows you to potentially roll your transfer structure into your floor framing, and then utilize some steel transfer structure to take the column spacing from the residential, and either transfer that into something that works with both the retail and the park, kind of respecting the parking grid spacing below, having your transfer up at the above the retail space, or potentially taking that transfer into the parking structure if you have the sufficient headroom space and things of that nature. So that really allows you to, once your foundations are done, that allows you to turn that over to the the steel and timber trades to start going, and from there, and to really utilize the offsite fabrication to speed up the erection process at that point. And then you're not you're not waiting on that last transfer slab and formwork and rebar and curing and all that time potential and risk potential there. And we found from high level costing that if you're able to go this route and eliminate that transfer slab, you're looking at potential saving of the structure anywhere from 10 to 20%. So it has, depending on what your extent of your transfer is and your change in your grid spacing, but there is a fairly good potential for savings and just risk mitigation from that standpoint. Looking at connections, mass timber works really well for moderately loaded connections, repeatable details, simple fire encapsulation. If you have typical framing with the moderate loads, very well developed details and simple for installation. Typically not no moments are typically hard to deal with. And then you want to kind of have simple seat and hanger details. And then when you get into your lateral system, oftentimes when you're dealing with residential, there's very even distribution of shear walls. There's not a high demand for your diaphragm to distribute lateral loads. So you're dealing with CLT spline details that are fairly light. Hopefully not dealing with a lot of strap plates, low drag force concentrations, things of that nature that are fairly easy to connect for. Then when you start getting into different building typology, if you don't have more evenly distributed shear walls, you can start getting into heavier connections, which become less efficient. If you have really complicated nodes, increased connection tolerances, if you have significant gravity or transfer loads, that's a big one to try to work out with. There are proprietary products such as the Megant connections you see on the right-hand side there. But when you start getting into really, really high loads and you're trying to start using multiple of these, the installation becomes quite challenging. So, doable, but tolerances and things of that nature become, and installation times become more tricky. And then when you get into, as you can see in the bottom left, bottom two pictures there, if you get substantial strap plates required for your diaphragm to pull lateral loads into your cores, that adds complexity and time to this. So again, you'll see where the benefits of the hybrid approach will come in. So when you have these really high concentrations of loads, that's where structural steel provides compact connections. Hopefully you don't see anything as beastly and unwieldy as the top right connection, but I figured I'd show that one just for the worst case scenario. But it gives you the ability to have very compact connections and transfer high loads, and ability to deal with moments and high tension, things of that nature, which steel really works well in. It also allows for the potential future reinforcement. Again, with structural steel, the materiality allows for welding reinforcement, things in the field that can be done fairly efficiently. And then lateral loads, a lot of that load transfer can be done inherently through just connections down to the steel. And that steel is fantastic in tension compression loads to transfer that load back to the lateral load resisting system. So it gives you some improved stiffness, reduces deflection and drift, things of that nature. So you can kind of see the benefits of the two approaches and intermarrying those materiality. We also look at construction schedule and sequencing. So again, mentioned a few times, you get the hybrid approach reduces site logistics issues like formwork, rebar congestion, curing times, labor intensity, and weather sensitivity. The improvements are if you're working together as a team, the cranes can be kept continuously productive. You're rolling trucks in, whether it's steel, mass timber, whatever it is on that day, you can just roll the truck in and pick it up and start lifting and erecting. And if that is a well-coordinated delivery schedule, then you're just continuously producing. Again, the upfront fabrication could potentially even allow you to fast track. If you really want to hit the ground running, you have a lot of material prefabbed and ready to go. you get a real quick jump on the structure as well. And then the floor structure allows for immediate accessibility. And then, it's a modular erection process where everything is coming in as a piece, a component of a whole system, and you're just putting it up there and bolting it in place. So very quick. So once the foundations are in place, the superstructure becomes more of a delivery and hoisting logistics exercise. And then cost and risk mitigation, safety. With the steel being fabricated off-site, you're not dealing with as high a labor force on-site. It's all done in a controlled environment, as you can see from the two sites, the two locations here. So you're not dealing with weather and other safety issues there. Shop fabrication is quality controlled. You reduce like I said, the weather aspects. You have a cleaner site with fewer temporary systems, shoring, things of that nature. Less working at height, less time spent, labor hours spent on elevated platforms, things of that nature. And then fewer trades are working simultaneously. Things are kind of happening with discrete groups at specific times. So you reduce the temporary risks with permanent structure earlier in the schedule. And then, so obviously there's always some challenges to address, and you never want to kind of brush those over and make it seem like it's perfect. So we have highlighted the following things that you really want to make sure you're on top of. A clear delineation of scopes between the different trades to ensure that everyone knows what they are providing in the structure, what connections are dealt with by what trades, the steel trade or the mass timber trade. As Lee mentioned, high coordination in the design process. Making sure that whatever structure is there is coordinated with the services, the finishes, and then just coordination between the connections and the materiality. There are different aspects in the way that steel and mass timber buildings will move through the construction process and lifespan of the building. Timber will have dimensional changes with moisture, and steel has dimensional changes with thermal expansion. So it's something just needs to be accounted for and make sure that connections are detailed properly to avoid kind of known potential issues. Then with construction, erection scheduling is a big one. Like I mentioned, if you are on top of that and have a great schedule, you have continuous production and your building goes up quick. Rust staining is something to watch out for if you have trapped moisture in the wood with steel in direct contact, making sure you're mitigating that. Make sure you're looking at how your inspections are done, just due to the fact that you may have encapsulation and things like that hiding some of the progress at some certain points. And then fire protection encapsulation could potentially cause trapped moisture as well. So quick summary of overall, hybrid structures provide numerous benefits, as we've talked, Lee and I have talked about. You have the expanded building typology based on the ability to have a longer grid. You can utilize, the combined structure on some of these structures that require more open space, clear heights, things of that nature. You combine the material strength instead of relying on just the material strengths of one type of material. You get the best of both worlds and the efficiencies of both worlds. You also get material biodiversity. So you get the natural sustainability of mass timber, and then with structural steel, you can also selectively source that, looking for electric arc furnaces, things of that nature, to get the lowest embodied carbon in your structural steel and really marry those up and get a great biodiversity of the building to obviously preserve sustainability goals, as pointed out there. The construction benefits is you shorten your schedules. You're not waiting on formwork, curing times, rebar placement. Everything is, for maybe lack of a better term, it's kind of the IKEA model where everything comes packaged up and it's plug and play, and the building goes up quickly. You're improving your safety. There's less labor hours on the site, less time spent at heights. So it's a great benefit there. Much better cost certainty from the aspect of you don't have the risks of delays, weather events, things of that nature. And you have upfront materiality in the drawings, and you don't have challenges with potential change of the formwork, things of that nature. And risk reduction, again, schedule is really king these days. People want, owners want buildings turned over faster and sooner, get occupancy, get the rent going. So having a system that goes up on a very tight schedule is a great benefit. So to kind of close my section here, hybrid mass timber and steel, the hybrid mass timber model, the steel doesn't dilute the value of the timber. It just allows timber to be used and perform best and remove some of the constraints to limit the project success. Pardon me. So I'll turn it back over to Lee and go through some examples of where this is happening around North America currently.
Perfect. Thanks, Scott. I think one good point just to kind of summarize Scott's last slide too is just the importance of early engagement with both the steel fabricator and the mass timber manufacturer. So a lot of these projects have a high level of coordination, but we're also dealing, especially on the mass timber side, with constraints that if they aren't kind of conformed to during the design process, that's when costs can get out of whack pretty quickly. So just having early engagement, bringing somebody on for a design assist, that's going to help you on two fronts. It's going to help keep your design cost effective, and it's going to help utilize or implement the construction schedule and make sure that you're going to have your factory time for either making the mass timber in our factory or fabricating the steel, and having those two merge together on site in the construction sequence and time frame that you want. Those are really key points to early engagement. So we always like to be engaged, I would say the latest point by 100% DD sets. I'd like to be aware of the project in schematic design and design development, or concept and schematic design, so that we can massage and manipulate the structural grids to make sure that they're cost effective for both of our products, and that we're not going to have any surprises on site. Offsite manufacturing is all about working through the details early, so that you're going to have a compressed construction schedule on site, and not have surprises that result in change orders and finger pointing and all the stuff that nobody wants. All that can be avoided with early engagement and working through the design details and the process properly, without having to rush it. To a certain extent, everybody's always in a hurry, but if we can get on and do that. So I mean, just an example here. This is 160,000 square foot technical school. It's in Kalamazoo, Michigan. The architect really wanted these wide open spaces, a lot of natural lighting coming in. So that's where this conventional steel frame structure worked really well in order to keep the depths of the beams down, keep the cost down. Typically, for mass timber, I'd love to say mass timber is a silver bullet, and a full mass timber building is the greatest thing ever for every single project, but that's just simply not the case. And typically, the more expensive part of mass timber is going to be that vertical structure. So the columns and beams that are supporting the roof deck or horizontal floor plate. So in this instance, you can see a few of the beams are actually glulam, but the primary structure, vertical structure there is just conventional steel. If those were glulam beams at those long spans, you would have ended up with a lot of fiber, some really deep beams, and it would have driven costs up. So what they chose to do here was a hybrid solution. But again, my roof deck in here, I want to keep my roof deck to my most cost-effective CLT panel. And my most cost-effective panel, for the most part, is either going to be a 3-ply, which is 105 millimeters or 4 1/8 inch thick, or a 5-ply. Now, a 3-ply panel can span about 10 to 12 feet, depending on loads. A 5-ply panel is going to span about 20 feet, give or take a foot or two. But that's when it's in a 2-span continuous condition. So I don't want to be delivering 20-foot panels. I want to be delivering 40-foot panels. I want to always be in a 2-span continuous condition. That's going to keep your installation time down because you have reduced number of picks. For installing mass timber, and I'm sure it's similar with steel, it's all about crane picks. How many elements can I install per day? So I want to have the largest amount of elements. I want to have the least amount of connection points. I want to have the least amount of water entry points so that you as a general contractor are not having to send somebody up there to do remediation because water came through and got a little bit of water staining. We got to sand that and buff it out, make it look nice. If I have the larger panel, I've left less of those water entry points. So it's all about structural grid getting our most cost-effective panel. So if a 5-ply panel can span 20 feet and you design a 23-foot wide or 23-foot grid, and then you engage your mass timber manufacturer and it's too late to go back and make changes, I might have to change that 5-ply to a 7-ply. And because cross-laminated timber comes in odd number of layered panels, 3, 5, 7, 9, going from a 5-ply to a 7-ply, I have to add 2 layers of 2x6s. So those are 38 mils per layer. So I'm basically upping my fiber by 30% to go from 5-ply to 7-ply. That will very quickly kill your construction budget. And also it adds weight and other factors. So understanding the structural grid, the constraints of the manufacturer, what species of wood they're working with, what their ideal panel sizes are. I always want to be maximizing my press in the factory. My press makes panels up to 11.5 feet wide and 53 feet long. However, I might not want to transport an 11.5-foot wide panel to site because it might need a chase car and kill the logistics budget. So you want to understand where you're shipping it to as well. If I'm shipping it to New York City, I can only send an 8-foot wide panel into the 5 boroughs. So there's little things like that are job specific, but typically I want to be around 10'2". That's my ideal width for a panel. So again, working with the manufacturer and the team early to get those ideal panel sizes in, that's what's going to give you a cost-effective project. And when designed well and mass timber or the hybrid approach thought out from the onset of the project, we can actually be extremely cost competitive with conventional construction, and you're going to get a better building out of it, and it's going to go together on site quicker with fewer change orders and more cost certainty. So that's the goal, but you really have to trust in the process and engage the supply chain early to come up with those cost-effective designs. Because the second you get outside of cost-effective design parameters, the costs go up really quickly. Cast-in-place concrete costs might go up this as you get into some wonky designs. Timber, they're going to go up very quickly. So keep within design constraints, engage your supply chain, early coordination, early engagement. That's what I'll say about this. This building turned out beautifully. You can see the connection detail from just a W beam to a CLT panel. It's actually quite simple, but again, it involves some coordination. So we're going to have the CLT panel sitting directly on that W beam, and we're going to have some pre-punched holes in the flange of the beam and just a self-tapping screw up from underneath into the CLT panel. So you want to make sure that even the flange of that beam is wide enough that it can have enough meat on the bones to get that screw in there. You want to make sure it's accessible. All these little details, really matter. And that's where us, Element 5, and our experience and our engineers and all the hybrid buildings that we've done, we can bring that to the table early. There's a couple different ways to do this to attach CLT to an I-beam. You can also put blocking on the top of the beam, and you can pre-install that blocking in the shop, and then you can actually screw down from the top of the CLT. That does involve adding extra material for the blocking, extra coordination, but maybe you have to accommodate a roof slope, so you've got some blocking to do that. So there's different scenarios that are going to involve different connection details, but also just that coordination on who's providing the screws, who's doing this. If there's a welded knife plate to a beam, maybe Scott's providing that and I'm providing the through bolts. So that's what we as a team like to do very early on with the drawings, just go through and highlight, this would be provided by us, this would be designed by us, this would be designed by us, but provided by someone else. So having that responsibility matrix on who's providing what, scope delineation, these are all super important to make sure that there's no surprises on site. All the scope is captured, there's no gaps, and everything is going to go smoothly. So this project ended up beautifully. I don't think I have a picture of the finished results. It's actually behind me, but we actually ended up cladding the steel beams there with our 3/4 inch nano CLT. So we have a decorative CLT. It's it's almost like beautiful plywood, but it's 3/4 inch 3-layer CLT that you can clad an I-beam with, you can clad a concrete stairwell with, you can make cabinets out of it. But we utilized it in this project to cover up the steel. So we've got next slide. So this one is the Enbridge Operations Center in Ottawa. So a beautiful office and operations center. We actually utilize steel here for the cross bracing. So you can see in the back there to help resolve the lateral force resisting system with some steel cross braces. So I would say a lot of our projects, almost all of them, end up being a hybrid in some sense. And it's kind of finding the balance of where wood makes sense, where steel makes sense, where steel cross bracing makes sense, where glue lam cross bracing makes sense. But again, there's always that level of coordination between the two trades. Element 5 can detail this. If there's enough structural steel, we're going to work with a steel fabricator. So I would say this project was leaning more towards a full mass timber solution. But again, it's bringing back to there's always going to be a structural steel component in it. Scott mentioned the drag straps to tie the diaphragm together. So we may have 1/4 inch or 1/2 inch thick steel plates dragging those loads back to the cores to resolve the diaphragm. Beautiful project though, ended up LEED platinum. Gorgeous. Next slide, please, Scott. So I want to just talk a little bit about student residences and higher education sector. So this is a project that we did last year in downtown Toronto, Trinity College. It's the Lawson Center of Sustainability. It is a 247-bed student residence, I believe, about 160,000 square feet. A large component of glue lam and CLT on this project, but in the student residence section, we actually utilized cold form steel prefabricated walls for the unit demising walls for the student residence. And we're starting to see that typology actually really pick up across North America. Is again, replacing expensive, I don't want to say expensive, but finding a more cost-effective solution for that vertical structure. In this case, cold form steel. It was a combination actually of CLT walls, so the students can see a CLT exposed wall on one side, and then the next unit demising wall would be cold form steel. So there's several large projects across Canada and the United States that are utilizing that cold form steel typology and a CLT deck. It can work extremely well. Next slide. Again, this is a good example of utilizing CLT in a horizontal plate. We came onto this project. It's Mitchell School. It's in Ann Arbor, Michigan. We're doing about 5 schools in Michigan right now. So the school district of Ann Arbor has a mandate to do mass timber on about 10 of their schools. We're currently working on 5 of them. And again, we came in very early as a design assist partner with the structural engineer of record, the architect, in order to cost effectively get CLT integrated into the floor and roof plate of this building. You can see on the second floor suspended slab there, we actually prefabricated on what's called a slope shield membrane. So it's a self-adhering temporary water protection membrane that goes on the CLT in the shop. So that just helps, reduce risks of water entering the CLT panels, keep your remediation as low as possible for any water staining, and protect the CLT during construction. I'd say our CLT typically comes out of the shop with a temporary construction sealer on it, so it already has some water protection, but some of the projects go a little bit above and beyond and put a temporary, like an actual membrane on the panels as they come out of the shop. So element 5 is promoting going that extra step just to protect the panels. This project, it was interesting. We really wanted to get our most cost-effective panels in there, but you have to work with the engineer of record very early on to understand what the snow drifts are, the loads, what those span conditions are in order to keep the roof at a 5-ply cost-effective panel size, as well as work with the installation team and the steel fabricator on the connection details, the delivery to site, the construction sequence. So we actually just topped out on this project a couple of weeks ago. We were waiting on the steel guys to finish up their scope so we could finish our deliveries here. But great project. We're super excited about more hybrids in Michigan. Next slide. So the Oakville fire station, this was an IPD project, and I feel like this one's worth sharing. We completed this one several years ago now, but we went into the IPD process not really knowing where mass timber was going to be integrated into this project. So we were sitting in the big room, if people are familiar with IPD, with the steel fabricators, with all of the trades and consultants, and just kind of figuring out what the best application was for each material to go in the building. So we came to the conclusion that in the apparatus bay where the fire trucks are, there's some very long open spans there you can see. So it ended up being a combination. Well, the apparatus bay ended up being open web steel joists, and then you can see the steel brace frames and columns. And then we ended up figuring out that the best application for the envelope was to use Element 5's clip system. So it's a prefabricated envelope with the air vapor barrier insulation and strapping on the exterior CLT panel. So it's a 3-ply, 4 1/8 inch thick CLT panel with air vapor barrier insulation strapping on the panels as they came to site. So we ended up wrapping the whole building in the clip system and doing the residential and office portion of the fire hall in full mass timber post and beam, tying into a steel structure for the apparatus bay. So it was a really good example of collaborating and just coming to honest decisions through open information during that IPD process to figure out what the best application of each material was. Excellent. There you can see a couple finished photos of that project. Turned out really nice. Cambridge Rec Center. This is one that's just finishing up right now in construction. You can see here again, utilizing open web steel joists and a CLT deck. So I go back to my point that one of the most cost-effective parts of mass timber is utilizing CLT in a horizontal condition for floors and roofs. So here, the connection detail between the open web steel joist and the CLT is it's a little bit trickier, requires a little bit more coordination and engineering up front. We had a great partner on this. And again, just free flow of information. One of the things that can really grind a project to a halt is just not getting RFI responses. So working with great partners and getting timely RFI responses, those really keep the design process moving. And in offsite manufacturing, I think that's one of the biggest hindrances is just, people not being forthcoming with information. So luckily we've been lucky to have great partners on a lot of our projects, and that's what real key to success to getting these things on schedule. So this is going to have a beautiful result here in Cambridge. Next slide. And this is one that Scott and I both worked on together. So this is the Prologis warehouse distribution center in Brampton. It's about 247,000 square feet. I think we're being generous, 250 there. But so this is one of the first, I think it might be the first full mass timber distribution center in North America. But we did have a good element of steel around the perimeter. Maybe Scott, you want to talk about your scope quickly on the perimeter of the building?
Yeah, so again, this kind of goes back to having your lateral system and your collector elements, with the steel materiality in order to be able to take, the fairly large tension and compression loads that you see in these large open space warehouses with not a lot of internal bracing. So that was where the steel was brought in to supplement that, and worked out some interesting details around the perimeter for the support of the columns and the linear support of the CLT panels, and we're able to keep that the lateral system nice and efficient, and then support the CLT and mass timber structure to the interior of the building, which Lee, you can kind of touch on.
Yeah. So, I mean, this project has 36-foot columns, 36 clear height, 40-foot columns. The structural beams there across the bays, they're 55-foot bays. They're about 4 feet deep. And then you've got a 3-ply CLT deck. So our panels were able to be quite large on this to get a rapid installation of the building. I think this was more of a full mass timber approach supported by the steel around the perimeter to resolve the lateral system. But I do see this building typology going more hybrid in the future. So there's projects right across Canada and the US that are utilizing a steel vertical structure with CLT roof deck, or a full steel building with a CLT envelope. So those teams seem to be the two approaches to these larger warehouse data centers, distribution centers. there's dozens and dozens of them being designed right now across Canada and the US, and they pretty much are all a steel hybrid, either with that mass timber envelope or mass timber roof deck, or a combination of those. So really cool to be a part of this project. So leave us, I think I'll hand it back to you, Sandra, to close out.
Fantastic presentation. Very eye-opening. It's invigorating to see that these buildings are starting to come up everywhere. The importance of the coordination that has to happen. There's certainly a few questions that come to mind, and you've mentioned the importance of design and your participation. And one of the questions I have is, what building types are you finding you're applying this method to? Are you doing it design build, design bid build? You mentioned the IPD.
Yeah, that's a great question. I can start it off, Scott. I mean, because of the early collaboration and involvement, I think what we do lends itself really well to design build, construction management, IPD, delivery methods. Those are the three that we kind of lean towards or see the most success with. The ones that we struggle with are more of the design bid build public procurement model or approaches like that, where the design has gone quite far into CDs, and then may result in some rework or inefficiencies. And also you're kind of got your back up against the wall in terms of schedule, because you get brought on, you win a tender, it's at 50% CDs or 100% CDs, and then they want shop drawings, and then you on site immediately, right? So there's a process, there's a backlog with the factory that we need to work with. And by bringing us on early in schematic design or design development, we're able to check both those boxes with design efficiency and plan in the factory for that. So for certain models that are more of a design bid build, we still try to push for a breakout package for mass timber or for anything that's prefabricated offsite. For us, we could also come on as a design assist partner and act more of as in a consultant way. So it's a separate breakout contract where we come on as a design assist partner, work through the details, get the building up to say maybe a building permit set or somewhere where it can go out to bid. So I've done several projects where it's going to go out to bid, but we've actually had that early engagement to make sure at least when it does go out to bid, it's going to come back as a cost-effective result and the project has more of a chance of moving forward. So early engagement means you're just increasing the chance that project's going to come back on budget. I may not win the project when it goes out to tender, but we're willing to make that investment into the project so that it does move forward and it gives us a shot to be the supplier in the end. So again, yeah, early engagement.
Yeah, totally agreed.
Excellent.
That's exactly the same thing that I would say from the steel standpoint. Gives us an opportunity to look at our proprietary products as well, to see how we can incorporate those. And but really it's getting the structure laid out in a way that makes sense, that has the right rhythm to it, that has the right grid spacings that work, because each supplier will produce things in a slightly different way, has slightly different methods and connection details, things of that nature. So if the design gets too far down the road, it's harder to really implement and make as much impact on the project, beneficial impact on the project, if it's in that spec bid build approach.
So one other quick question before we sign off here is the building inspectors and working with the engineers of record. I would imagine this is quite new to everybody. How do you deal with that?
Yeah, I would say it's not quite as new as it used to be. There's quite a bit of precedence in the industry now, and a lot of AHJs are getting quite familiar with mass timber. There are still going to be some that are not, and engineers. The design community is expanding, so more engineers of record are starting to want to design in mass timber, and that's why we built up such a strong engineering team, is to help empower those projects and help support those design teams. We're not trying to be the engineer of record ever. We're trying to empower the project in whatever it needs. So if you're working with Aspect or Fastenep or Thornton Tomasetti or somebody, really high level mass timber engineer, you may not need as much involvement from Element 5 or on the mass timber design. However, we still want to be involved to a certain degree for the scheduling and just little intricacies of the design. but going back to the authorities having jurisdiction, we're here to support that, and I think engaging them early and making them a part of the process is a real key to success. So the more that they know, the more comfortable they're going to feel. And if we don't have the answer, Scott and I can point you in the direction of somebody that does. So great acoustic consultants, great fire consultants, great, code consultants in general. There's a lot of information out there now, like Woodworks is great at supporting these projects. So you just need to be pointed in the right direction and feel comfortable. And
the hybrid solution also provides some comfort level as well. For you get the city inspectors, I'm sure just having that hybrid effect just smooths the process over a little bit, I guess. But yeah, no, I think everything in general, you're starting to see acceptance in the codes and inspectors and review teams. So it's exciting.
Well, thank you so much for a fantastic presentation, and thank you for our viewers for joining us. Please remember that the TCA is always looking for exciting people who would like to engage in the environmental committee and bring in their new perspectives, as well as we're always looking for companies to become green ambassadors. So feel welcome to contact the TCA at the address attached. And the seminar will be posted on the TCA YouTube site. Thank you so much, speakers, and thank you, viewers, for joining us. Have a great day.
Thank you, everyone.
Thank you.